So an alternate approach was actually put forward quite a while ago, which is by Leighton in 1955, and this is using what's called a Leighton Flexometer. It's a gravity-dependent flexometer. Now, the way these work, you have two gravity-dependent needles. So we have an internal and external track. So the red represents the internal and the blue represents the external. And they are in essence two protractors going in opposite directions. And any point you move that device, unless it's locked, they spin. So they're absolutely gravity dependent. So what we do is we strap the device, and we strap the device not to the joint of articulation. You have to remember now with this, it's about where is the most distal point in relation to the joint that's been articulated. So let's say you're assessing the angular displacement at the knee. You put the flexometer on the outside of the ankle. And then they would articulate through extension and flexion around the knee. And this will then reflect as these protractors and these needles rotate. That then gives you, if this is the knee joint, I can get extension and I can get flexion around the knee. It's actually been shown to be quite reliable, particularly in the lower limbs, which is a real positive, because the thing that you don't have so much of an issue here as we had with the goniometer is the implications of practitioner experience. And you can see here, these are some examples taken actually from the original manual from Leighton, and they just show you where the goniometer is placed in terms of elbow flexion, and shoulder extension. And you can see the same here, hip flexion, hip adduction, knee flexion. All of those show you where the goniometer is placed and how the movement is then performed. And remember, what you've got is these needles that are moving as the limb is being displaced. And that's the real difference here. When you're using a goniometer, you're placing its axis of rotation on the axis of rotation around which you're assessing. With the flexometer, you're actually placing it at the most distal part of the limb in relation to the joint that is being articulated. And again, these are taken from the original manual. And again, you can see where the device is being placed, but you can see this can be used for pretty much any movement. That's kind of the positive aspect of this device. But Coupon again says there are problems with reproducibility and variability, and they are inevitable due to the fact that there is no agreed upon standardized approach to measurements of range of motion. There are no standardized features of instruments. The variability of the instruments and their application does not lend itself to consistent readings or comparability and the dynamic nature of the human body and its condition. So even though the Leighton Flexometer actually looks like a much, much more robust device, it hasn't changed since 1955. There is no digital version. It's incredible. And the reason really is because there isn't a big enough interest in this area. So there's never been a call for manufacturers to develop it. It's incredible. I mean, it's ironic that now on your iPhone or any kind of smartphone, they come with devices that allow you to record angles. They're probably better if you can find a way of strapping that device on than using a conventional Leighton Flexometer. How reliable is it? Well, there's almost no data on this at all. So we have to go right the way back to this from 1983 to help us. Here we've got our flexometer, session 1, session 2, session 3. It would appear in hip flexion in this example to be very repeatable. And the thing you can take away from this, which you don't have with the goniometer so much, is that actually this is probably more about the repeatability of the participant than it is the practitioner. Whereas the goniometer is absolutely about the practitioner. So it does suggest there's fairly good reliability here. Again, a data set which was kind of used, and it's again, you have to question the information that's been provided. Again, it's relatively old, from the 90s. But what we've got is we've got elbow flexion, shoulder extension, hip flexion, knee flexion, and so on. And what we've got here is we've got them being assessed with different tools, goniometers, Leighton flexometers, and so on. I just want to compare the goniometer to the flexometer, to our clear square, to our solid square. And actually what you can see is there are suggesting actually if we look at things like shoulder flexion, it's quite quite a big variability there. If we look at something like our shoulder abduction, quite a high degree of variability. The same if we look, for example, at hip abduction. So they do seem to be having differences. Despite the fact they're both assessing angular displacement, there do seem to be profound differences. And so you have to go, well, where is that variability coming from? And it's almost certainly the difference between a goniometer, which is practitioner variability, and a flexometer, which is participant variability. And if we look at the data here, so here we've got our goniometer and our flexometer. So if we just look at our this is our flex EG3, and we look at our gon flex, you can see there are quite big differences within the data sets. So it really, despite the fact these are much, much more direct than our kind of sit and reach tests that we've been referring to previously, there are inherent variabilities here, which using things like a dynamometer to assess range of motion takes out of account. But you've got to have a really expensive piece of kit. It's not portable. It's not valid to take into the field. It's the same using 3D motion capture. So there's a real kind of gap here in terms of our understanding.